Hello everybody, welcome to my chemistry channel Bldash, short and sweet in chemistry. Now I am going for the topic, a fundamental concept of organic chemistry. This is part 11 when I am going to explain that is Carbanion. Carbanion. What is mean Carbanion? Carbon plus anion. What is anion? Negative charge. And what is cation? Positive charge. So here carbanion means carbon having negative charge. Then how it will be formed? Now see, carbanion compound, organic compounds containing a carbon atom carrying a negative charge. If you see in organic compound the carbon carrying a negative charge, you can say that carbon is carbanion. A carbon atom, if you go in the explained way, a carbon atom with a pair of electron, that means negative charge should be present and also a pair of electron present, where on the central carbon. The central carbon atom is called a carbanion. So if you want to explain properly, you say carbon with a pair of electron. You see, pair of electron must be represented with negative charge on the central carbon atom in a compound. On the central carbon atom which occupies a pair of electron and negative charge, that is called carbanion. Then come to what is the meaning by carbanions in regarding electrons. Carbanions, I told, it has a pair of electron. It indicates that it is a electron rich species, electron rich fragments. So what happened? Very active intermediate. It is sure carbonium, and also know that is one type of intermediate, and carbanion also very active intermediate. Then here carbanions, if it contains negative charge and pair of electron, that should be attracted by electrophile. What do you mean by electrophile? Electrophile means loving, electron loving. Who will love electron? That having less electron or positive charge, they will attack electrophile. Now carbanions here means carbon plus anion. It is carbon and with negative charge, it's a pair of electron, I already told, and simultaneously you have to observe 8 electrons should present in outer shell. What is meaning 8 electron? Because you know 1s2, 2s2, 4, that means 6 electron in the outermost shell of carbon. When it occupies a pair of electron, that is why negative charge. And what is the number of electron now? 8 electron. That means it is electron rich species. So what would be the nature of the electron species, electron rich species? That means it is a tendency to give electron to other. Then only it is proceeding for reaction. Carbonium ion has a central carbon atom with a positive charge. When you compare, when you observe what is difference between carbonium ion and carbanion, see, then only you can understand easily carbanion. Carbanium means it is a central carbon atom with a positive charge and also less electron than outer shell, say 8 electrons. That means 6 electrons. It has 6 electrons. When it form a compound, the electrons should be 8 electrons after combination. But here 6 electrons, and that is deficient of electron. That is why, see, the pair of electrons, since B is electronegative atom, then compared to A, then what happened? It comes to B. And A become less electron, and electron removed. That is why plus sign, and it is minus sign. Similarly, if you take an organic compound having X as a that is more electronegative, then what happened? It acquires the C and having 3 bond and plus sign. What you can observe, there is no bond present, and that is plus sign, so it is less electron, 2 less electrons, so it is 6 electron, or you can say sextate electrons. So here X minus having that is a pair of electron, it indicates that it is more electronegative than carbon. That is why it acquires a pair of electrons with a negative charge. Carbanion is a central atom. Now, when you read carbanium ion, it is a positive. And when you read carbanion, it is a central atom with a pair of electrons and negative charge. Then what happens if it is a negative charge? See, this is carbon. In carbon, what happened here? 3 bonds are there, and it is here sidely one pair of electrons with a negative charge. Now it is a carbanion ion. Example, you can take CH3 methyl Z is a 1, where you can observe this Z is less electronegative and C is the more electronegative compared to Z. That is why this pair of electron comes to this carbon. Then what happened? C acquires a pair of electrons with a negative charge and Z become positive charge. So what is the name? Since the group is methyl. What is the group here? Methyl. So the name is methyl carbanion. According to the alkyl group, the carbanion ion attach. Carbanium ion 6 electrons if it has a tendency to accept a pair of electrons. But carbanion, what happened? 8 electrons, it can donate a pair of electrons to others. Very interesting, carbanion and carbonium. Now when you proceed carbonium or carbanion ion, let us first see heterolysis of covalent bond. Only possible carbanion or carbonium only by the help of heterolysis. Heterolysis means here the side which is more electronegative, the pair of electron which forms the organic covalent bond that breaks, and the pair of electron goes to more electronegative part, then is non-organic molecule. If the carbon atom has high electronegative, suppose if the carbon atom instead of X, in one case X may be more electronegative than carbon, where the carbonium ion is produced. But when the carbon atom has high electronegativity, then X atom, what will happen? It takes electron pair from X and acquires a negative charge because the carbon has high electronegativity than X atom. So now see, if the pair of electron will form the sigma bond with X and X is less electronegative than carbon, then what happened here? This electron moves this side and it acquires a negative charge with a pair of electron and X plus. And this carbon with having negative charge and pair of electron called carbanion ion. I hope it is clear. Heterolysis means what? The transfer of the electrons towards the more electronegative atom. If X is more electronegative, then C become plus. If X is less electronegative and carbon is more electronegative compared to X, then what happened? The electron pair comes to the carbon having negative charge, and that is called carbanion ion. So what is conclusion? How can know that is carbanion? An organic ion with a pair of electron and a negative charge on the central carbon atom is called carbanion. Are you clear? Last conclusion, what you are getting? Organic ion, suppose having pair of electron, negative charge on the central carbon atom. Remember, on the central carbon atom is called carbanion. Carbanions are named. How we will name the carbanion? It depends on the alkyl group. That means parent alkyl group is attached to the word carbanion. Now see the example. If it is CH3, CH2 minus with a pair of electron, because it is the alkyl group is ethyl. I told parent alkyl group with the word carbanion. So it is called ethyl carbanion. Are you clear? Since ethyl group present, ethyl carbanium. If it is propyl group, here what happened? If it is propyl group, then what happened here? Here isopropyl carbanion. It is called isopropyl. Carbanions are electron-rich species. What is mean electron-rich species? More electrons are there. and that is produced after heterolytic fission. In heterolytic fission, carbonium ion and carbanion are produced. Carbonium ion containing positive charge and carbanion that is containing negative charge. So since electrophile is electron loving reagent, and that is why electrophile is attacked by your carbanion ions, because electrophile is electron loving, and whereas carbanions are electron donating nature, pumping electron towards electrophile. So carbanions ions are unstable due to negative charge. Why? Because it contains a pair of electronegative charge, and that is why it is very unstable. And also it contains 8 electrons also. And electrophiles, example NO2 plus, H plus and H3O plus. Electrophiles are positive charge. So how can you say other groups, if attacked by the carbanion ions, what happened? Carbanions are stabilized. Another point. Carbanions are stabilized by the presence of adjacent group. What is that group? Cyanide, carbonyl. Now what happens in, after I will show you the reaction with CN and with carbon, how it is connected with electrophile. How it is connected with carbanion. They are classified as primary, secondary, tertiary. Then why and how? Depending on the number of carbon atoms. Carbon atoms 1, 2, 3, then what happens? If carbon atom which contain negative charge and a pair of electron, to which how many carbons are attached? If 1 attached, primary, if 2 secondary, 3 tertiary. Now see, this is the methyl, and where you can say there is a carbanion present because it containing negative charge with pair of electron. This is primary, because R contains C, this contains, there are two carbon compounds and here attached to the, R is attached to here, that is what is primary. And then secondary, 2 are attached and 3 are attached, this is tertiary. If 1 are attached to the carbon negative charge, that is primary. And now instead of R it is hydrogen, that is also primary, but it's called ethyl carbanion, primary carbanion, secondary carbanion, tertiary carbanion. The order of stability how? Actually in carbonium ion, the tertiary is more stable than secondary, then primary, then Ca3 plus. But now it is in reverse condition, Ca3 minus, more than primary, more than secondary and more than tertiary. So electrophile means what? Electron loving, it attract electrons from carbanion ion, or you can say carbanion donates a pair of electron to electrophile. Example, how the cyanide group is attached, how the electron pumps through, which way, see here. Now cyanide group, with nature, what is that? Withdraws electrons from carbon having negative charge. Now see here. Now what happened here? If it pumps electron from carbonium ion, withdraw electrons from carbanion ion, then what happened? Then here negative charge on the carbon decreases, because in carbon there is a negative charge, pair of electron. If we donate electron to cyanide group towards, then what happens? Negative charge decreases and carbanion becomes more and more stable. If alkyl group is present, then what happens? If CN group is present, the negative charge on the carbon in carbanion ion decreases, more stable. If alkyl group attached, you know what is the nature of alkyl group? Alkyl group is electron donating. It will donate electron, pumps electron towards in the wavy structure, wavy line towards the carbanion ion. So it is less stable than this. Then this means this is simply hydrogen. Here what is that? R, alkyl group. Alkyl group is electron donating. That is why it gives electron to the carbon containing negative charge. That means it, what is doing? Electron density decreases. Electron density increases, because from this R it is moving towards carbanion. So electron density increases on the carbon, so it is less stable than simply hydrogen attached to the carbanion ion. Is it clear? If CN group is attached, withdraws electrons from carbanion ion. If alkyl group is attached, which alkyl group donate electron towards carbon negative charge, when the electron density increases. If increases, it become less stable. Now, if alkyl group pumps electron through the wavy bond to the central atom carbanion, increase the electron density in carbanion is less stable. But in case of benzyl carbanion, it is more stable than simply aliphatic carbanion, because in benzyl carbanion, it is stabilized by the resonance. It has stabilization that is due to resonance, and now in ethyl carbanion there is no resonance. So how in aromatic ring, here alternative double bonds are there. Alternate single and double bonds are there. Then what happens? See, this is the benzyl carbanion, and there is a negative charge CH2 group is attached to benzene, and the canonical form, see here, this is the canonical structure. You can observe this is, it comes to this side, and there is a pair of electron, so it changes to double bond, and this pi electron localized to this carbon becomes unstable, so it is containing negative charge with a pair of electron. And after that, you can see in second structure, this pair of electron moves towards this carbon, and this bond rupture and comes to the carbon having pair of electrons. So see here, then this is the carbon having pair of electron. This is a bond, now it is produced, and that bond before it is present. And now again this bond breaks and comes to the carbon, localized to this carbon that containing single bond, negative sign, that is negative sign having a pair of electron, and here the bond, the single bond of that changes to double bond. Here the bond was there, but now no bond. Now what happened? This pair of electron having negative charge comes to this bond, it becomes a new pi bond, and now here the pair of electron comes to the carbon having this charge. You can observe this one. What is the difference? Here all are same except alternative single and double bond. In this case, this side three double bond present, and here in this side 3 double bonds present. That is called Kekulé structure. The alternate double bonds are changing the position. And now here also same thing I have explained. You can see here the electron jumps and how the double bond remain as it is, but here the electrons, where pair of electrons are there, how they localize to near the carbon bond, carbon bond, and lastly these are the canonical structure of benzyl cation produced. So what is the conclusion? The order of the stabilization depends on the inductive effect, that is of alkyl group. So alkyl groups are electron donating nature, releasing group, that is donating electrons to the which one? Carbanion. So what is the nature of alkyl group? If it increases the electron density on the negatively charged carbon atom, that is carbanion, then it automatically makes unstable. And if any group which withdraw electrons present, then it is easy, the electron density of carbon decreases and more stable. So larger the alkyl groups attached, and here the electron density or negative charge on the carbon atom will be more and more, density increases, and that is lower stability. So if more alkyl group, more unstable. If less alkyl group, more stable. If there is any group that is electron withdrawing group present, it withdraw electrons from the carbanion, then it is more stable. So what is the structure of carbanion? When you observe the structure, and it is the sp3 hybridization. In carbanium, that is sp2 hybridization, and here it is sp2 in carbanium, and here it is sp3 hybridization. You know sp3 hybridization, and 4 orbitals are produced. Out of 4 orbitals, 3 are overlapping with the s orbitals of hydrogen, forming 3 sigma bond. Here 3 sigma bond produced, but out of 4 sp3 hybrid orbital, one is unhybridized, and here it contains a lone pair of electron. Actually, in sp3 hybridization, the structure is tetrahedral structure. But actually what happened here, due to repulsion between lone pair, bond pair, and bond pair, then here the structure not exactly tetrahedral, but it is pyramidal structure. So out of 4 sp3, one is 3 are sigma bond and one is containing lone pair of electron, and condition is hybridization not takes place here by using this orbital. The fourth sp3 orbital, that is containing a lone pair of electron and carbanion, I told, due to repulsion, and it has pyramidal structure. Reactions of carbanions. Carbanions are electron rich species. Here addition substitution reaction takes place. Addition reaction. Carbanion are they are adding to the carbonyl group. Then what happened? Addition reaction, see here adding to the groups, that is aldehyde, ketone. But what is the main group present here? Carbonyl group. The carbonyl group present in aldehyde and ketone. This is called carbanion, and here electron pair is there that moves towards this carbonyl group. This is carbanion. So what happens? See, as C double bond element as it is, it changes to CS2 single bond, and here the last O containing a pair of electrons with a negative charge. This is one type of addition reaction. Then come to conclusion. Conclusion mean of carbonium and carbanion. What is here conclusion? You know, carbonium and carbanion both are produced by heterolytic fission. See here, when there is a pair of electron and Z is more electronegative than carbon, then automatically C plus produce and Z minus produce, which is called carbonium ion. This is sextet electron, that is 6 electrons present, and so it has a positive charge, and also act as a active intermediate. Conclusion, hydrolytic fission, how the carbonium ion produced, and here sp2 hybridization takes place. What hybridization takes place? sp2 hybridization takes place. And what is the stability here? The stability mean, here the stability always tertiary more than secondary, more than primary, more than CH3. And now heterolytic fission also gives carbanion, where Z is less electronegative compared to carbon. So carbanion, and here sp3 hybridization of carbon atom having a carbon center, negative charge with a pair of electron. Here stability is just opposite to the stability of carbocation, or can say carbonium ion. CH3 minus charge more stable than primary, more stable than secondary and tertiary. So here it indicates that carbonium ion also unstable and carbanions also unstable, but here carbocation is very important and is also having so many reactions in compared to carbanion. So I hope the carbonium and carbanion both are clear to you. In this video only I have explained carbanion comparing with carbonium ion, and before that video, that is I think the video 10, you can observe what is carbonium ion, how it is proceeding, how the reaction takes place, what is the structure of carbonium ion. Please, before reading carbanion, before seeing carbanion video, please go to carbonium ion in part 10. And now it is part 11 where carbanion is explained properly. Thanks for watching my video. Thanks again to all.